Okay, this lesson here is going to talk about the cube root function. But before I talk about the cube root function, what I do need to discuss is what is a cube root function? Okay, notice this little 3 there on the top. Okay, this means instead of having 2 of the same number, you need to have 3 of the same number in order for it to be taken out. Let's focus on this one, the cubic root of 27. We need to have, since there's a 3 on the outside, we need 3 of the same number. Okay. 27 breaks down to 9 and 3. 9, whoa, that was funky. 9 breaks, that's even more, oh, because I have a mouse right there. Oopsie doodles. 9 breaks down to 3 and 3. Now I've got 3 of the same, meaning that the answer is going to be 3. That's very important to understand. That number outside the radical indicates I need that many of the same number. Let's actually talk about another one real quick. The 4th root of 16. 16 breaks down to 4 and 4, 2 and 2, 2 and 2. 4 of the same, it's 2. So that's crucial, okay? Crucial. Negatives are also allowed to exist, okay? Negatives are also allowed to exist, and I'll show you why, okay? Negative 9 and 3, 3, negative 3, okay? So keep in mind this, okay? Yeah, what it becomes negative 3. It can be 3 of the same, does not matter. As long as even one of them are negative, it's actually going to be a negative answer, essentially, okay, whenever we're dealing with odd numbers. So the cubic root function actually extends downward compared to the square root function, where it extends only upward. This one does both. The important point, boop, is still going to be 0, 0, and it stretches. It's like a spaghetti strap, right? B, whoop, and B, whoop, like that. This is for the cubic root of x. Okay, so there's no restrictions. Every x can give you an answer, and every answer is possible. So the domain and range are both all real numbers. Okay, so let's talk about shifting, however. Okay, maximum values, and just basically plug them in. Boop, boop. Just plug them in. At negative 8, the answer is negative 2. At 8, it's 2. There's your minimum. There's your maximum. Boop. There you go. Okay, maximum minimum values for this over from negative 27 to 27. Let's graph that real quick. Let's actually use Desmos, as a matter of fact. Okay, let's take this off, take this off. What I'm gonna do instead is this, okay? I'm gonna do this. I'm gonna go x to the power of 1 over 3. It's actually gonna be the same exact thing. And let's find out at 27. Let's make a table for this real quick, okay? So I'm gonna do that, take that off. 27 is 3, negative 27 is negative 3. Oops, there you go. So there's your answers there. We're actually gonna use the table now to find the answers, okay? You can use the table, as a matter of fact, to find your answers, and then from there you can make your slope equations if you need to, okay? So keep that in mind for sure. Not difficult at all. Here we go, moving on. How does a graph compare? Same thing, okay? If it's outside, we move it up and down. So the important point will move up 4. So it's 0, 4, okay? If it's inside, that does change things, right? If it's negative, it moves to the right. Positive, it moves to the left. Notice how it's inside, it's a positive, we move it to the left. The important point here is going to be negative 6, 0. Boom, we got it, okay? This one here, how does it compare? Boop, boop. We move it down 2, and we draw the same squiggly line, beep, beep, just like that. And the important point is 0, negative 2, okay? This one right here, boop, boop. We move it left 1, boop, and boop, just like that. The important point, negative 1, comma 0, okay? Let's look at the next example here, okay? Modeling a problem using the cube root functions, okay? Basically for this, all you got to do is plug in the numbers, and then you're basically making comparisons, okay? When I plug in 9, I get 1. When I plug in 16, I get 2. So it'll increase between 9 and 16. It goes from 1 to 2. Basically, that's it. Okay, a cube has a volume of 10 cubic centimeters. A larger cube has a volume of x centimeters. This is the function that you're using. Boop. We're going to plug in 14 and 19. Let's do it real quick. And we're going to use x minus 10 to the 1/3. Okay, so let's take this off. Okay, here we go. Parentheses, x minus 10, okay, to the power of 1 over 3. There you go. Let's make a table for this. We're going to compare 14 and 19. Boop. 14, 19, there you go. Note, oh, that's 9, 19. There we go. Notice how it's bigger, right? It's about a half bigger, 0.5 bigger from 14 and 19 in comparison, okay? So there's your answer there, okay? So what are the values? So as obviously as the volume increases, we can then say that or as x increases the dimensions, we can say the volume is going to increase for sure, okay? So here we go. For the functions here, average rate of change. Again, when you see those words, you're thinking slope, okay? So you want to think slope. Yes, you plug them in. Yes, you find your answers. And then you have to find the slope between those two values, okay? We're doing it for both, okay? Notice this, obviously, depending on the numbers, it can increase or decrease. Just make comparisons, okay? So let's do this. Compare the average rate of change for this function, okay? Between here and here and here and here. Let's do it real quick, okay? Let's actually make a table for this, okay? So here we go. 2x minus 3 to the 1/3. So it's 2 parentheses x minus 3, oops, and then risen to the power of 1/3. Boop, there you go. Let's make a table for this real quick, okay? And we want to find the answers at -12 and -8, okay? So at -12, -8, there you go. Notice how it's going to be a bigger slope, okay? It's 8 actually. Oops. There we go. There, it's actually going to be a big comparison. So 4.9 and 4.4, okay? So at 4.9 and 4.4, here we go, okay? 4.9 minus 4.4 over -12 minus 8, that is going to be 0.5 over -4, okay? So there we go. Let's do -4 and 0, okay? Here we go. All right, -4, oops, -4, 0. There we go. So it's -3.8, -2.9, okay? -3.8, -2.9, let's do that. So minus parentheses -2.9, okay, over -4 minus 0. That is going to be positive 2.9, so it's going to be -0.9 over -4. Oops, so it's actually bigger because two negatives will make a positive. Do the same thing with this one here, this last one. Basically comparing average rate of changes based on the given function, beep, bop, boop, that's it. So let's do this example here real quick. Use Desmos, cannot stress enough. Let's make an equation for this to the right one up to, okay? It's going to be the cubic root of, to the right one, so it's x minus 1, and then plus 2, and then, or this function, okay? So between -5 and 0, we got to see which one's a bigger rate of change. We can actually see it visibly, okay? Here we go. So we're going to go parentheses x minus 1, okay, to the 1/3, plus 2. And then on the bottom, we're going to do radical x cubed plus 3. Okay, so it's going to be x to the 1/3. Okay, and then plus 3. We got to see which one has a bigger rate of change. Okay, so let's compare between -5 and 0. Okay, so here's -5 to 0. And notice how this actually has a smaller rate of change compared to this, because between -5 and 0, boop, it actually gets bigger quicker, as a matter of fact, compared to this. So we can say the one in blue, which is the x to the 1/3 plus 3, has a bigger rate of change compared to the one in red, which is the x minus 1 to the 1/3 plus 2. Okay, you can do it visibly, essentially. Okay, now to conclude that lesson, 10-2, 10-3, coming right up.